My name is Molly Johnson, and this is my lab video for Lab 2, the Tape Lab, Part 2. And just for the record, the application that I'm using to screen record this doesn't allow me to do full screen, which is why the presentation is not in full screen. Purpose. So the purpose of this lab was similar to the previous lab, and that was to use household objects, in this case pieces of tape, to calculate charge. We used equations such as F equals ma, F equals QE, and E equals KQ over R squared. We were to emphasize the difference between assuming a point charge versus calculating the charge distribution over an area. There's a heavier focus on coding on this lab than the previous lab. Data collection. So the length of the tape was equal to 20 centimeters or 0.2 meters. The mass of the tape was 0.2 grams or 0.00002 kilograms. The force of gravity on tape B, which was the top tape, was equal to F equals ma or 0.002 newtons. And the electric force on the tape is also equal to the force of gravity, since the tape is not moving, which means it is also 0.002 newtons. The distance between tape A and tape B was 1.5 centimeters or 0.015 meters, and using these numbers we could calculate the electric charge of tape B, which was equal to F equals QE, or 7.1 times 10 to the negative 9 coulombs. So this is the result of my GlowScript code. As you can see, tape B, aka the top tape, is represented in red, and tape A, the bottom tape, is represented in blue. The green arrows represent the electric field vectors from the bottom tape on the top tape, and the white arrow represents the force of the electric field from the bottom on the top, and that is the summation of all the green arrows. The yellow arrow on the bottom is the force of gravity. And as you can see, the magnitude of the electric force is also equal to the magnitude of the gravitational force. So within the code, I put in the mass of the tape, which was 0.002 kilograms. I put in Q, which was the charge of each individual piece of the tape. And I entered my function to calculate what the electric field would be for each piece of the tape. As you can see, between the top tape and the bottom tape, there is a distance of 0.015 meters, which would be the unit, and that represented the space in between the tapes as the top one was floating above the bottom one. And here I have a scale just so that you can see both the tape models and the arrows nicely on the screen. And then here I edited that the force of the electric field of the top tape by the bottom tape is equal to the charge of the top tape times the electric field at the top by the bottom. And then I edited the vector of the electric field at the top so that it would be visible. Lab questions. What was the magnitude of the charge on one piece of tape as calculated by your computational model? In this case, Q was equal to 1.9 times e to the negative 8 coulombs, and this number was chosen so that F of G would equal F of E, aka the forces of gravity and the electric field would cancel each other. What assumptions, approximations, or idealizations did you have to make? We assumed that there was no air resistance and there were negligible other forces. We also assumed that there were no forces between particles on the same piece of tape, aka there was no effect of tape A on A or tape B on B. And each piece of the tape had the same charge magnitude. What if you had modeled each tape as a single point charge? Well, we would have gotten the results from Lab 1, which are less accurate because things in the real world are not just points in space. They have volume and they have area. Why do these estimates differ? Which value is more likely to be closer to the real value and why? Again, one accounts for shape and volume of the tape and the other does not. In this case, the Lab 2 results are more accurate. Conclusion. So, the lab purpose was to study how charges react to each other similar to the first lab. However, there was a heavier coding aspect to Lab 2. We were to visualize the sum of the point charges of the tape using the model as produced by the GlowScript code, and we also showed that f of g is equal to f of e. And that's it for my presentation. Thank you for watching.